Today's video will be on congruence and quadrilaterals. So our learning goals for today: by the end of the lesson you'll be able to decide if two special quadrilaterals are equal, and you'll also be able to prove that diagonals of a parallelogram bisect each other. So, just a bit of a recap, just for you to remember some basics about some of these special quadrilaterals. So a kite, we've got a picture of a kite here, is a quadrilateral that has two pairs of adjacent sides that are equal. So we can see here that they've got two pairs of adjacent sides and those pairs are equal. Okay, so there's one diagonal of a kite that bisects the other diagonal. So this diagonal of the kite bisects the other diagonal of the kite. So bisects means it cuts it into two equal parts. So this line here is cut into two equal parts by the other line there. The one diagonal of a kite bisects the opposite angle, so it also cuts the angles equally in half, and the diagonals of a kite are perpendicular to each other. Okay, so we've got a trapezium here. So remember, a trapezium is a quadrilateral with at least one pair of parallel sides. So we've got the parallel sides here. They're the pair of parallel sides. So a parallelogram, which we've got here, is a quadrilateral with both pairs of opposite angles being parallel. The opposite sides of the parallelogram are equal. So this side is equal to this side is equal to this side, and the opposite sides are also parallel to each other, and the diagonals of a parallelogram bisect each other. So again, the diagonals cut each other equally in half, so straight in the middle. We've also got a rhombus. So a rhombus is a parallelogram with two adjacent sides equal in length. You can see that here with our dashes showing that each of the adjacent sides are equal in length. The opposite sides of a rhombus are parallel, so like the top and the bottom are parallel, and the left side and the right side are also parallel to each other. So all sides of a rhombus are equal. We just went over that. The opposite angles of a rhombus are equal as well. The diagonals of the rhombus bisect each other, and the diagonals of a rhombus bisect each other. I've written that, sorry. So the diagonals of each of a rhombus bisect the angles, I should say. So each of the angles are cut equally in half by the diagonals, and the diagonals of a rhombus are perpendicular. So a rectangle is a parallelogram with a right angle. So you can see each of the corners is a right angle. The opposite sides of a rectangle are parallel. So this side and this side are parallel, and that side are parallel. The opposite sides of a rectangle are equal, so this top side is the same length as the bottom side, and this left side is the same length as the right side there. All angles at the vertices of a rectangle are 90 degrees, so every single corner is at a 90-degree angle. And the diagonals of a rectangle are equal, so it's equally across both ways of the diagonals there, and the diagonals of the rectangle also bisect each other, so they cut each other equally in half. So a square, so remember this is kind of like a rectangle, so it's a rectangle with two adjacent sides are equal. So this side and this side, this side, this side, all the sides are equal. So opposite sides of the square are parallel. So again, the top and bottom are parallel, the left and right are parallel. All angles at the vertices of a square are at 90 degrees. Every single corner is at a 90-degree angle. The diagonals of a square bisect the vertex angles. So again, they're cutting those angles perfectly in half, and the diagonals also bisect each other, and the diagonals of a square are perpendicular. Okay, so after all that, hopefully that refreshes you on each of those shapes. We've got some worked examples. So we have to prove that the triangle ABC is congruent to triangle ADC. So triangle ABC is congruent to triangle ADC. So we can think back to all our rules and think which one of those rules for congruence of triangles does this picture satisfy. So the first thing I would look at is they both have a right angle. So we've got angle ABC is equal to the angle that we've got for ADC. So they've got one equal angle there. They also share a hypotenuse, so you can see they're both pointing to the hypotenuse, so they share the hypotenuse. So AC is common to both, And then they also have a corresponding side. So that's supposed to be a B. So AB, that length there, we know is equal to the length of AD because they've got the same marking. So it's, it's equal to AD. So if we look there, we've now satisfied our rule, RHS, because they have the right angle, they both have the same length of hypotenuse, and they both have the equal side. So satisfies RHS test. So triangle ABC is congruent to triangle AD and C. So that's how we've got some proof there. So our second worked example is a little bit more complex. So this worked example asks us to prove that the diagonals of a parallelogram bisect, which means to divide into two equal parts. So we have to prove that the diagonals of the parallelogram bisect each other and give reasons for that. Okay, so this is our parallelogram. We've got to prove that this line and this line actually bisect each other, so cut each other equally in half. So the first thing we're going to look at is we're going to look at this kind of Z shape here. So I'll redraw it here. I've kind of got this Z shape here. This line is equal to this line. This is D, C, A, and B. So not only are they equal in length, they're also parallel. So what we should know from this, we should realize then that this angle here is actually equal to that angle here. So our angle BAE is actually equal to our angle D, C, and E. And the reason for this is alternative, and again my pen is changing colors for some weird reason. Let's see if I can fix that. Right, so alternative angles in a parallel line are equal. I don't know why it keeps changing color. Anyway, so we know that here. So then if we look carefully, we can kind of see we've actually got the opposite the other way as well. So if we were to draw it the opposite way, and this is still D, this is still B, A, B, these lines are still equal and parallel. By this logic, we will also have corresponding angles here. So we'll do that big open circle, and here these angles should also be equal. So that way our angle, ABE is equal to our angle there of CD and E. And again, that's because alternative angles in a parallel line are equal. Alternative angles in a parallel line are equal. So I should probably mark E on these to make it clear. So E is kind of in the middle here. So if you didn't know that, that's probably something useful to know, that these parallel lines, so the two lines like that, if we were to cut, join them together, the alternative angles within that are equal. So that would be very useful knowledge, and it's going to apply in a lot of these situations. So now we've got two angles that we know are equal, two pairs of angles that we know are equal, and we can look at this and we can also find some other things that we know that are equal. So if we look at the side AB, obviously in your book you'd work down the page again, but I've run out of space. AB, we know it's marked with the same line that D and C is marked, so we actually know that AB is equal to that line D and C, so they're the same length because that's given. Equal because it is given. So now that we know we've got a few equal angles, we also know that we've got equal side lengths, we can then look at our congruence rules. So what rules have we satisfied there? So think about it, we've got some equal angles and we've got an equal side. So we know we can then satisfy that rule. So triangle ABC is going to be congruent to triangle CD and E. So this triangle, this is ABE. So this triangle here that I'm going to colour in is going to be congruent to this triangle here. The reason that we know that is because we've proved they've got two equal angles. So we know that this angle is equal to this angle, and I'll swap colors. We know this angle here is equal to this angle here, and we know that this side is the same length as this side. So they've satisfied that rule, that AAS rule, because they've got angle, angle, side. Because it satisfies that rule there. And then because we know that because these triangles are congruent, we obviously know that they're exactly the same shape and exactly the same size. So that must mean that B to E is exactly the same length as D to E, and C to E is going to be exactly the same length as A to E, because if they are congruent triangles, they're exactly the same shape and exactly the same size, which means those lines have to be exactly the same. So for that reason, we know it has to bisect this. So obviously you'd keep all this working and go down the page. I'm going to have to clear my page to make it clearer. So therefore B to E has to be equal to D to E, and C to E has to be equal to A to E. So therefore the diagonals bisect each other. So we've proved that using our rule that alternative angles in parallel are equal, and we've satisfied that AAS rule, and then from there we've figured out that this line has to be the same length as this line, and this line has to be exactly the same as that line, equaling these diagonals bisect each other. So hopefully that is clear, and it shows you a way we can use all these different tests for congruence to solve problems. And again, any issues, please make sure you ask in class.